Hey guys, it's Mr. Sheeline. This is going to be the video covering the Unit 4.1 notes, motion, and speed. Okay, so getting straight to it, let's just take a peek here at the good student learning objectives. So for this learning objective, or for these learning objectives, here are the three that I'm hoping that we can accomplish in this section of the unit. So I want you guys to be able to at least define the term one-dimensional motion. This is going to be a fairly simple term, as we'll see in just a bit. I'll walk you through, because we should know what one-dimensional means and how it applies to motion. And then we're going to identify a scalar quantity. Again, a fairly simple idea, and we have to make sure that we understand what a scalar quantity is and what a vector quantity is. We'll get into vector stuff later on, but we're going to learn what scalar quantities are real quick in this lesson today. And then simply calculating speed using distance and time. This third one will also extend to calculating distance using speed and time, and also calculating time with distance and speed. Okay, so let's just go straight to it. So one-dimensional motion. So what is one-dimensional motion? A really simple answer is motion that is measured on a single plane. So this is super duper simple motion. It's stuff that we are, for the most part, it's only in, one plane. So meaning, is it on the x-axis? Is it on the y-axis? Are we going north to south? Are we going east to west? Okay, it's as if something is traveling on a straight line. Okay, now it can travel on a straight line, turn around, and then travel back on that same line. Okay, that is one-dimensional motion. So examples that we have here, a man walks eastward, so meaning he walks to the east at a rate or a speed of 2 meters per second. Okay. And then here as an example, a car drives north at a rate of 20 meters per second, brakes to a stop, and then drives south at a rate of 25 meters per second. So in this case, the car was driving north, was like, oh shoot, I forgot, my oven's still on, turns around, and then drives south at a different speed. So this would be still one-dimensional motion because they're, on a single plane. They're moving north and south, okay, in a straight line. So something that we have to understand about one-dimensional motion, just motion in general, we can break motion down, and I really should just say motion, so almost ignore, looking at this now, ignore one-dimensionals in here, because this is true really for well, I guess it's not, because that's changing. Never mind. Don't listen to me on that quick second. I take that back. Don't cross that out. Okay, it is actually one-dimensional motion. Technically, we can break this down into uniform and non-uniform motion. And what those are is, you have uniform motion, which is, movement at a constant speed in a straight line. So you're going, and we'll get to some examples here in a bit. Where non-uniform motion, this is where your movement changes either in speed or direction. Okay, so examples of that would look like this. They would look like, let me get my mouse. So examples of uniform motion, it would be like, well, a car drives east at a speed of 30 meters per second, okay? Or a penny is dropped from your raised hand. Or a bullet is shot out of a firearm at a rate of 350 meters per second. Okay, these are what we would call this is uniform motion in the general sense. Now, will the bullet eventually fall to the ground? Obviously, yes. Eventually, it would. But when we talk about things in physics, and like this, when we're calculating, we're practicing, we kind of fudge it a little bit, and we kind of, how to put it, we kind of see some things and we put some other things to the side, because in order for us to really get an idea of what's happening and what we're measuring, we've got to really focus in on a couple on the most important elements of it. Okay, so that's why, yeah, of course, if we know anything about bullets, yeah, gravity is going to affect it eventually, and it's going to change its speed. It's going to change its motion due to gravity. Okay, and yeah, so but in certain cases, we just kind of say, It's at a constant, we're going to say the bullet was shot out at a constant rate of 35 or 350, meters per second. Now, in non-uniform motion, this is where we have a change in speed or direction. So, and as an example here, it'd be like, well, a car applies the brakes and comes to a stop. Okay. So whatever speed they were traveling at, they're hitting the brakes, they're coming to a stop, and now they're not moving at all. So there was a change in motion. There was a change in speed. Okay. Or a rocket that starts at rest, okay, at 0 meters per second, the opposite of this first one. A rocket begins rising from a launch pad. So it's going from rest to moving. Okay, so there's a change in speed. Okay, and then a motorcycle driving west turns around and drives east. So here we would have technically, or at least as far as we can tell, there's a change in direction. Or at least just direction. It doesn't exactly tell us if there's a change in speed. Maybe he was going 5 meters per second or maybe 2 meters per second. And so he was going pretty slow. So he was able to, turn really quick without really changing his speed. But he still changed directions. And because he changed directions, that is non-uniform motion. Okay. So here are some examples, again, of what non-uniform motion looks like, what uniform motion looks like. So let's try to, let's give these a try. So what I want you to do, after I read out this problem, this check your understanding, after I read this out, I want you to pause the video. I want you to answer these on your own, and then come back and see if you're correct. So let's read through it. So for check your understanding number 1, using the following examples, identify the examples that describe uniform motion and those that describe non-uniform motion. Okay, so pause the video, look at these, write uniform motion, write non-uniform motion off to the side, whatever you need to do, and see if you get those right after you've got those answered. So pause the video here. Okay, so a rubber stopper dropped from your raised hand. So what we described there is pretty much what we talked about before with the penny. That right there is going to be uniform motion. Okay. So I'm going to write it like this. So uniform motion. So UM will be uniform motion. Okay. So let's see. I'll circle that and then I'll make that red, and then I'm going to make blue non-uniform motion. Okay. So a car traveling at a steady rate, so meaning it's not changing the rate in which it's moving. It's not changing its speed. It's moving at a rate 85 miles per hour due west. So right there, that's uniform motion. Okay. So the third one, a rocket begins rising from a launch pad. We just did that one. This guy is going to be non-uniform motion. So num. Okay. Non-uniform motion. Motorcycle rider applies the brakes to come to a stop. Again, this is going to be a non-uniform motion. And then a roller coaster crests a hill and then falls down the ramp. So here, that means that you've got like the roller coaster car here. It's coming up, but it's slowing, and then it goes down. Okay, so we have not only a change in speed, but we also have a change in direction here as well. So in this case, again, this is going to be non-uniform motion. Okay, so hopefully you got those. Hopefully you kind of understand the difference between uniform and non-uniform motion. Again, if the examples aren't terribly clear to you, just really look at those or look at the definition. Uniform is moving in one direction. It's in a straight line and it's at a constant rate. Okay. So if there's nothing that tells you that there's a change in speed, if there's absolutely nothing that tells you that there's a change in direction, you have uniform motion. But if you do have something that says, oh, you're changing direction or your speed is changing, then that is where you have non-uniform motion. Okay. Oh, excuse me. And so this moves on to now us really getting into what speed is. So because motion, we describe motion and we can measure motion in multiple different ways, and speed is one of them. We'll get into others down the road in different unit sections. We just want to focus in on speed right now. Okay, so speed is the measurement of motion without direction. Okay, so we can say that something is moving in a particular direction, but really that's just describing that it's moving in a straight line. We don't associate the direction with the speed. It's just the magnitude. It's just how quick are you moving. Okay, so what we would then call that, we would say then speed is what we would call a scalar quantity. And so a scalar quantity, like it says here, these are quantities or measurements that have magnitude, meaning they have size, but they don't have any direction. Okay, so examples of that, like down here, would be like, kilometers per hour, meters per second, miles per hour, kilograms, centimeters, grams, all of those. They're all scalar quantities. They're just saying, here's how much you have. Okay. It doesn't tell us the direction. Okay. Or at least, again, we don't associate the direction with those quantities because we don't really care about the direction as long as we know it's on a straight line. What we care about is just how quick and how slow something, or what's the size of this thing. Okay, that's what we care about. So that's a scalar quantity, and those are the examples for a scalar quantity. Now we practice this a little bit. Okay, so calculating speed, well, we need two things. We need distance and we need time. Distance, we're going to be measuring for the most part and exclusively, we're going to be measuring in meters or kilometers in this class. Yes, you can measure distance in miles and inches and feet, but I don't want to get you guys terribly confused, and I want to really, practice using metrics, the metric system here. So we're going to be measuring in just meters and kilometers for distance, and then for time, we're going to be measuring in seconds and hours. Okay, more seconds than anything. There will be some questions where I'll ask you to calculate, something in kilometers per hour, but I'll give you the time in hours and I'll give you the distance in kilometers. Or if you're finding distance or time, I'll have the speed in kilometers per hour, if it's that case. Okay. So we need those two things to calculate speed. And then since we're working with multiple variables and we're also going to have to know and identify those variables, this is how we lay those out before we get into that formula. And we need to understand them. So speed, for speed, we use the symbol for V. The reason why we use V is we use V for speed and velocity, but velocity has a little difference it'll have a slightly different little arrow, or it'll be slightly different because it has an arrow above the V, and we'll get to that section when we get into velocity. We'll get to that later. The reason why it's not S is because there's a lot of professors and there's a lot of teachers that will measure distance, or they won't use the symbol D, they'll use the symbol S for distance. They'll also use S for a term called displacement as well. So because they use that for displacement and distance, they don't use S for speed. They use V just because, you can go between speed and velocity, between scalar quantities and vector quantities. And again, we'll get to that later. Just know that speed here is, speed uses the symbol V. That's what you need to know. So when you see V with nothing else around it, we're working with speed. Distance, we use the symbol D. Easy enough. Okay, we use D for distance. And then time, we just simply use T. That's it. Okay. So V for speed, D for distance, T for time. So not too difficult here and pretty straightforward. Okay. Now we've seen this little triangle before, and you're gonna see it quite a bit as we practice this. So, and we've seen this this formula before, but let's make sure we have it in the notes. So, and now that we know the variables, it's going to be V or speed is equal to D over T, distance over time. So again, really utilize this little guy over here, this guy right here. Got to really use that. This basically cheat sheet triangle will save your life when it comes to doing these calculations. Because if you forget this, but you've got this, or you remember this, you're golden. Or let's say in that split instant, like on a quiz or a test or something, or on a homework assignment, you forgot, like, what do I do if I have, speed and distance, but I need to find time? What do? I don't remember. You can go over to this guy right here, and you can find time by, covering up time and then seeing, oh, it's distance over speed. I've got to divide distance by the speed, okay? So very much a tool that you should use, and that we're going to be using here a little bit in just a second when we go through the rest of the check your understandings, because there's quite a few, okay? Okay. And then as we have practiced before, we can use the speed triangle and easy algebra to find any of the three variables using the speed formula. So as examples here, if we need to find speed, it's v is equal to d divided by t. If we need to find distance, it's d is equal to v times t, so speed times time. And then if we need to find time, it's going to be distance divided by speed, okay? And again, I'm giving you all of this. I'm giving you all of this right here now, so you can remember, okay, each of these and how to find each of these, how we use algebra to find all of these guys, okay? But you also have this. You also have this guy right here, okay? So we've got the formulas. We know how to find speed. We know how to find distance. We know how to find time. So let's put this to the test, and let's give this a go, okay? So let's go with your check your understanding number 2. So again, I'm going to read this out, and then after I'm done reading this out, I want you to pause the video, go on a scratch piece of paper, do this yourself, and then come back to see if you get the correct answer. So, okay. So reading this here, I'm grabbing my calculator real quick. So reading this, check your understanding number 2. You need to get to class 200 meters away, and you can only walk in the hallways about 1.5 meters per second. If you run any faster, you'll be caught for running. How much time will it take you to get to your class? Now, before you try to solve for this, you need to do this. You need to identify the variables you know and the variables you don't know, okay? So meaning you're going to write down the variable symbols for speed, distance, and time, and you're going to tell me, like you did on the assignment last, I think it was Friday, you're going to tell me what the variables are and what their quantities are. So how speed is equal to what, distance is equal to what, time is equal to what, okay? So pause the video here, identify those variables and their quantities, and then solve. Okay, so let's take a peek here. So first I'm going to identify the variables. So it looks like here I'm given distance. So I need to get to class, and it's 200 meters away. So that's distance. And that's 200 meters. And you can only walk in the hallways about 1.5 meters per second. So that's going to be my speed, 1.5 meters per second. Okay. And then I'm being asked how much time will it take? So T is going to, well, we don't know what it's equal to, so it's got a question mark. Okay, so now I've identified my variables and their quantities. I know what I have and what I don't have. So I've got distance and speed. So now I'm going to write down the formula, which in this case, the formula is going to be T is equal to D over V. Okay, so I've got my formula, and now I'm going to plug in my numbers. So T is going to be equal to 200 divided by 1.5. That's 200, not 260. By 1.5. And I'm going to plot that in my calculator. So 200 divided by 1.5. Well, that's going to give me time here of being, I'm just going to go to just 133 seconds. Okay, and then I have my answer right there, 133 seconds. Now, something I just realized that I didn't really include in the notes, which I will include a slide that you can obviously read yourself after making this video. I really didn't talk about, the need to have units and to really emphasize, having the correct units at the end. So I'll make sure I'll add a slide chatting about that. But this is going to be something that I need you guys to include from now until we're done with motion. You really, and actually forces as well. When we write these answers, you need to have the correct units. So in this case, we didn't find just 133. We found 133 seconds. Okay. Why is it seconds? Because we're finding time. Okay. We're not finding distance. We're not finding speed. We use distance and speed to find the time. And in this case, the time is measured in seconds. Okay. Now I'll walk through that again. I can walk through that again. We'll see if it works out in the other examples here and emphasize how it is that we get the units that we should be getting for each answer. But again, for this one, it should be 133 seconds. So when we do this on worksheets, if you don't include units, I will take points off for not including units. You have to have units. Okay. It's imperative. So let's take a look at the next ones. Okay. So a track star aiming for a world outdoor record runs 4 laps of a circular track that has, oh, for goodness. No, we're going to skip this one. Skip this one. I'm sorry. I thought I changed this. Actually, we're going to change this in here. I'm going to make sure I change this. Like before I post this video, I'll change the notes. I thought I changed it already. Runs 4 laps of a circular track. We're going to get rid of this radius business here of a 400 meter or circular track. Actually, we're going to do circular track. No, yeah, that makes sense. Of a 400 meter circular track. Okay. In 50 seconds. Which is insane and I think is impossible, but we're going to go with it anyway. What is the runner's speed? Okay, so this is this is a crazy superhuman doing this this task here because shoot, man, I think the world record for just running 1 lap for like an adult male is something like, I think it's like 42 seconds last that I checked. So running 4 of them in 50 seconds is, now that's a dude. That's Superman right there doing that. So let's even though this is a bit wacky, let's solve this anyway. So okay, so let's say you need to pause this, solve for this, and then play the video, and then come back to it. Okay. Okay. So hopefully you've got the right answer. So let's identify the variables that we have and what we don't have. So we have distance. Okay, so we've got not 400 meters. This person didn't run 400 meters. They ran 400 meters 4 times. So the distance here is going to be 1,600 meters, which is almost equivalent to it's almost equivalent to a mile. It's a little bit under a mile. So the idea that they did this in 50 seconds is, again, inhuman. But we're going to solve for it anyway. So distance is 1,600 meters. The time, we have in the time, we've got 50 seconds. And what don't we have? Well, we want to know what the speed is. So V, we don't know V. So it's going to have a question mark. Okay, let's write down the formula. So V is going to be equal to D over T. Okay. And then let's just plug in and calculate. So this dude ran 1,600 meters in 50 seconds. So it's going to be 1,600 divided by 50, which is going to give us a speed here of 32. Oops, that doesn't look like a 3. It's going to be 32 2 meters per second. Okay, meters per second. So that means that for every second, this dude ran 32 meters, which again, that is insane. And then he did it for 1,600 meters. It's crazy. But again, impossible as far as we know. Maybe this is a bionic man for all we know, you know. Okay, so you arrived in my class 45 seconds after leaving math class, which is 90 meters away. How fast did you travel? So remember, you got to identify the variables, and you also need to, or the variables you know and the variables you don't know. Okay, so pause the video here, identify those variables, solve for this on your own, then hit play to see if you got it right. Okay, so what do we have here? Well, the first thing that we're given is going to be time, which time is going to be 45 seconds. And then you left math class, which is 90 meters away. So we have distance, which is 90 meters. And we want to know, how fast did you travel? It's asking us bluntly, what's your speed? We don't know our speed. Okay, so we're looking for velocity, we're looking for speed here. So it's going to be V is equal to D over T. Okay, so we've got the formula, we've got all of our variables. Let's plug them in the correct spots. So V is going to be equal to 90 over 45, okay, which is then going to give us an answer here of simply 2 meters per second. So a nice brisk kind of trot or walk. Okay, it's not too fast, not too slow. You're going pretty quick, okay, but it's not running, which is good. Now, real quick, just again, because I did say I wanted to go over this. Why is it that speed here has the units of meters per second? Well, easy. We traveled 90 meters in 45 seconds. And really what we're trying to do is that we're trying to turn this guy down here into a 1. So that's why we're dividing 45 by 90. Okay, because we want to say in 1 second, this is how many meters you're going to travel. Okay, this is the distance you're going to travel pretty much on average in 1 second. Okay, so that's why for speed here, we've got the meters up top, we have the seconds below, and when we calculate it, it's going to turn into 2 meters for every second. Okay, no different from miles per hour, right? How many miles are you going to travel on average in this one, or in an hour? If you're going 60 miles an hour and you're able to go exactly that speed, okay, you're going to travel 60 miles in 1 hour. Okay, same thing here. In 1 second, you will travel 2 meters. Okay, so that's what we're saying here, and that's why it's meters per second. And we'll get to the what about distance and time. Hopefully, I'm trying to remember if I've got those, but we'll see. Okay, number 5. So in a competition, an athlete threw a flying disc 139 meters through the air. While in flight, the disc traveled at an average speed, or just a speed, of 13 meters per second. How long did the disc remain in the air? Okay, so what we're saying here is so what it's asking here is what's the time? So what this is implying is that once that the disc hits the ground, the disc is no longer moving. The speed is 0. So from the moment you release it to the moment it hits the ground, what's the time? Okay, so identify the variables you know, identify the variables you don't know, solve, and then see if you get this right. So pause the video here and go ahead and complete this. Okay, so let's identify those variables. So we've got a disc that's going to travel a distance of 139 meters. And it's going to travel that with a speed of 13.0 meters per second. And we're trying to find time. How long did it stay in the air? What's our time? Okay. So in this case, since we're trying to find time, it's going to be T is equal to D over V. Okay. Distance divided by speed. So we've got our variables, we've got our formula. Let's plug it all in. So T is going to be equal to 139 meters divided by 13, which when we plug that in, 139 divided by 13 is going to be, time-wise, it is going to be, we'll say 10.7 seconds. Okay, and that would be our answer there. Now, this will be going, so 139 divided by meters divided by 13 meters per second. Now, how do we get seconds at the end here? Which that is an S. This is an S, not a 5. Okay. How do we get seconds? Well, remember, like I showed you in the video last week, okay, meters are going to cancel out here. And when you have a denominator in a denominator, so the seconds here, it's basically you putting it up here in the numerator. Okay, it's you putting it all the way up to the top. And so the units you're left with are seconds. Okay. You can that's the technical way. What you really could think of is, well, I'm solving for second or for time. My units here, there's meters and there's meters per second. I should be left with seconds. That's what makes sense. I cannot be left with meters. I cannot be left with meters per second because I'm solving for time. I don't measure time in meters per second. I don't measure time in meters. I'm only measuring time in either seconds or hours. Okay? I shouldn't have those units in there. If I do, something's wrong. Either I've calculated something different or I accidentally put in the wrong units. Okay, so always be looking out for that and always make sure you have the correct units when solving for these. And then the last one, a really simple one. If you move 50 meters in 10 seconds, what is your speed? Remember, identify the variables and then calculate. So pause the video here, calculate all those good guys and make sure you have the variables listed out. We'll see if you got it right. Okay. So let's calculate this. So if you move 50 meters in 10 seconds, so we're moving 50 meters, so that's our distance. Okay, we're moving 50 meters. And we did it in 10 seconds. So time is going to be 10 seconds. What is your speed? It's just straight up asking us, how quick were you moving? So we don't know what our speed is. So to calculate speed, it's going to be V is equal to D over T. Okay. So we've got our formula, perfect. Got all of our variables. Let's plug them into the right spots. So it's going to be V is equal to 50 divided by 10. And it's going to be 50 meters by 10 seconds. And this one we can do in our head. This is super easy. Speed is going to be equal to 5 meters per second. Bada bing, bada boom. Okay, easy peasy. Okay. Oh, sorry, scratching out here. So that is the notes there, guys. Remember, you're going to have like 1 or 2 slides that aren't included in this video just because I realized I didn't include them. So make sure you really read and understand those slides. And if you need to, get a hold of me if there's something you don't get about them, or if there's anything you don't get about, or if there's something you don't get about in another part of the notes. So again, another emphasis on making sure that we are including our units. That is going to be something I expect you guys to have in all your answers moving forward. And also expect that when we get back to hybrid, also expect that worksheets that you're going to complete, you will have to show your work. While we're in full remote, I'll have a note for this. You don't need to show me work, but once we get back, you need to show me work. Okay, and we kind of already did this already when we were working on the Unit 2 material. But just a heads up there, okay? All right, so again, that's the notes. Get a hold of me if there's something you don't get. But if not, I will see you guys in the next one.